So you've built a beautiful mesh environment, and you've already added mesh visual scripting to create triggers that lead to actions, creating visual interest and interactivity that keeps your participants engaged. But what if you want to go beyond interactivity? What if you want to bring in real-time data, both from the public internet and from your own Azure resources? That's what Mesh Cloud Scripting is for. Hi, my name is Alex Turner, Principal PM Architect on the Mesh Toolkit. And I want to give you a quick look today at Mesh Cloud Scripting, the way that you can go beyond just interactive environments to make your environments truly live. Bring in real-time data and integrate complex business logic so that everyone gets the most powerful and current experience. So in previous videos, you've seen how you can use mesh visual scripting to make your environments come alive, reacting to simple triggers with actions that everyone in the scene can see. Mesh visual scripts sync your script variables and your scene changes across all users, and they let you build custom low latency interactions. But what if you want to make your world not just interactive, but live? With Mesh Cloud Scripting, you can call any .NET API and bring in real-time data from your own backend web services. Deploy code into your own Azure subscription and directly modify your scene objects in one place with automatic synchronization to all clients. Mesh Cloud Scripting works by mapping your Unity scene objects up to the DOM objects you have in your cloud scripts. The components that don't have a mapping, like the particle system here, can still be controlled by animations in the Unity scene or by you turning on and off their parent objects. Each Unity scene gets a Mesh Cloud Scripting subfolder that has a C# project in it. Mapping from your Unity scene into that server objects is done by the scene.map file. And then inside app.cs, that's where you start to write your core logic. You start to fill out the start async method, and you wire up to further event handlers. All right, now let's see all this in action in Unity and Visual Studio. So I've loaded up a simple art gallery project here. You can see it's got a set of picture frames arrayed around a central area that maybe 1 to 4 people could view the scene in. And each one of these picture frames, if we click on it, we can see is made up of a web slate. So this is something that can show a web view. Right now they're set to about blank because they're not loaded yet. There's also the frame that surrounds it. You can see that there is this gray sphere in front of it, kind of a simple little subtle sphere that's going to be used if we want to refresh the art to show different art. And then a little trigger volume. You can see this sphere here. If you walk up to it, when you stand within that sphere, we're going to show a little bit of detail information in the upper right. And if we were just showing static images, if we just baked 12 images into the scene, we wouldn't need to go out to do cloud scripting. But the special sauce we want is we want to go out to the Art Institute of Chicago, their REST API, to pull art from their catalog. We want to pull down some public domain images and show them in the gallery. So kind of each time we go back here, the art is fresh. So how do we go about this? You can see here, if we go to the root Mesh Cloud Scripting object, there's a Mesh Cloud Scripting component here. And over here where it says Open Application Folder, right, this is what's going to give us access to that backing C# project. This is the project that when you deploy your scene to Mesh, you're also going to be deploying your project up to Azure to run the scripts in the backend. So if I click here, you can see that I've got the art gallery folder come up here, and I can load artgallery.csproj, and this is going to load up Visual Studio. Okay. Once we're in Visual Studio, I'll load up the app.cs file. This is the main file where you're going to add your code for the project. And you can see we've already got some code here inside start async. This is the main method that's going to get called when your scene initializes. And you can see what we're doing here is going through that Mesh DOM API to pull out the key nodes that we care about from that Mesh Cloud Scripting route that we've set up over here in our scene. And so the first thing we do, for example, is we find the first child labeled artwork. So that's going to go here and find this node underneath here, the transform nodes in the Mesh DOM API. They map over here to the game objects in your Unity scene. We then loop over each of the children game objects, the child transform nodes here. And for each child of artwork, we're going to call update artwork. And this is our other method, our helper method down here, which is going to take each one of those nodes and dig into it. And you can see, for example, like we have this node here. We kind of zoom in. What are we going to do for each one of these art pieces? So, we're going to go to our little backing artwork API to call back into the REST API and query the next page. We won't dig into the details there, but this is going to get us that kind of payload from the JSON that comes from that API. And then we're going to pick a random artwork from that result that we get. And from that, we're going to pull out the web slate node here in the scene. So we're going to dig to the child under this particular node here. That is the web slate. So we're going to find that here. And specifically, it's the web slate node. It's not finding the node called web slate. It's finding the component as a child that is of type web slate. One interesting thing with the mesh DOM is we don't have a separation between objects and components. They're all one big tree. So we're just searching that tree to find this web slate component here. Once we find it, we set the URL to the content URI from that JSON payload we got for the art. And then we also pull out the artist and the title, and we set these artist and title nodes. We set the text on the text mesh pro here that maps to this text node, and we set those texts to the other data that we pulled out from the JSON. And so we go back up here then. So that was us setting up the artwork initially. But then, we also want to set up that refresh button so we can get new artwork. So for each one of these artwork children, we pull out the interactable node. So interactable node, if we go down here to the refresh button, we can see there's a mesh interactable setup component. And what this does is at runtime, this turns into something called a mesh interactable body. And this is what makes a given object at runtime in your Unity scene interactable. Users can pick it up or move it or click on it. In this case, we have equipable and manipulable unchecked. So the only thing they can do is kind of click on it to activate it, to select it. So when that refresh object is actually selected, we're going to have a callback here, and we're going to call that same update artwork function so that we can run it again and get a new piece of artwork. So then after we've done that, we just have one more thing to wire up, which is that trigger. So remember that little sphere, that volume that we're going to use. If you step inside there, we want to show the details, the artist and the trigger, the artist and the name of the artwork. But the important bit is we only want to show it to that person who had stepped inside the trigger. So you can see here how even when we're on the cloud server, we're able to do this per user logic by saying, here, get the trigger, get the geometry, which is that kind of sphere collider that we have there, and then fetch that details node here, which represents that thing. You can't quite see it yet, but it's the kind of artist and the title that are going to appear to the upper right. And then we say when the geometry is entered, when somebody actually enters that area, we're going to take that details pane, we're going to set it active for a specific participant, specifically the participant who actually did the entering. We're going to pull the participant out of that event args. And then when they leave, we're going to say that it is not visible for them, right? So this is how we're going to turn that visibility on and off for that particular person and ensure that only that person sees it rather than everyone else kind of see the noise of the info flicker on and off if they're standing farther away. Okay, so now that we have our cloud scripts ready to go, let's actually try this out in play mode. And so I can click play up at the top. And importantly, I don't actually have to set up Azure or connect out to a real cloud service in order to test what I've just done. With Mesh Play Mode, I'm able to test all the things that I'm creating in my environment myself here inside Unity, including the cloud scripts. We actually will run a local cloud host for you and let you see what your cloud scripts are doing even before you deploy up to Azure. All right, we've connected to our cloud server that's running locally, and you can see the artwork is starting to pop in. And then if I turn around, if I look around inside Unity here, I can look at the various pieces of artwork, and they've all kind of loaded into these individual web slates. And then if I use WSA and D to move around, you can see that when I step close to a piece of art, it's showing me an artist and the name info that came from that API. If I go to the next one, it's showing me that in particular. And if there was somebody else here, they wouldn't see that unless they also stepped inside the same sphere as me. And then also you can know if I click here on the little refresh sphere that I created, it goes out and it fetches a new piece of art that has new information. And there we have it. We've created a simple scene that goes out, it fetches data from the cloud, it pulls it back in. I was able to do this very naturally, do it inside .NET. I was able to call into .NET APIs, including those that fetch from the cloud, just as I would in any other application. But then I'm able to directly go and reach into my Unity scene and make the changes that I need to make through that Mesh DOM API. So as you just saw, with Mesh Cloud Scripting, we follow some key principles to make it straightforward and simple to develop applications that are multi-user and also live in real time. We have all of our logic synced and late joinable by default. Every action you take, every poke you do in the Mesh DOM API, all that stuff happens automatically for everybody across your scene. But when you want to do per user effects, you can. It's always intentional and you always know that you're doing it, but it is possible, and it lets you build multiplayer games or experiences where one person gets some kind of custom trigger for something that they're doing. We also, as we said, make this as simple as we can for you. The target that we look at is the notion of local couch co-op. We want this to be as straightforward as it would be on a single console when you had multiple inputs coming in. Because you have one common thread of execution running on the server, you don't have to worry about different client code, your code running across different machines getting out of sync. Everything will just work across that one common thread you have on your cloud server. And importantly, we give you the full visual expressiveness of Unity. Even when there's nodes like particle systems or other things that we don't have mapped yet into the Mesh DOM API, you can still use animations, you can still use parent objects to turn those things on and off, and you can get that full visual expressiveness for every component we can let you use inside Mesh. With visual and cloud scripting together, you can build rich interactive environments, and you can make those environments real-time and connect to your business data. So what will you build? To get started, go to aka.ms/meshdocs and click the other links in the description. Thank you.